Hi, today we're going to create a solder mask for a custom printed circuit board using the Bantam Tools desktop PCB milling machine. A solder mask protects circuit boards from oxidation and helps prevent solder bridges from forming. To make our circuit board, we'll first mill the traces, remove the PCB from the mill, apply the solder mask, then reinsert the PCB and mill away the parts of the mask where we want the copper exposed. And finally, we'll finish the board by milling the holes and the outline. We'll be using a UV curable resin, a UV light, some plastic sheets, a spring-loaded engraving end mill, a PCB blank, and the precise and reliable Bantam Tools desktop PCB milling machine. We'll begin by creating an SVG file for the tool paths to cut away the excess solder mask, exposing the pads. Download the Eagle to SVG ULP file available on the Eagle website. Load the board design in Eagle and isolate the T-stop layer so it's the only one visible. Then, using the command line, execute the ULP using the run command, followed by the ULP file location. Follow the prompts and you'll have an SVG in seconds. Load your original board design file into the Bantam Tools desktop milling machine software and mill the traces. We'll do the holes and outlines later. With the traces done, go ahead and remove the PCB from the mill. Put on a pair of nitrile gloves and place a small amount of the solder mask resin on the board. Cover it with a plastic sheet and gently push the resin into place. Here, we're using an extra piece of polycarbonate to press down and spread the resin as even as possible. If you haven't used a resin like this before, it may take a few attempts to get it right. Next, use a UV light to start the curing process. The time it takes depends on the type of light and how thick the resin is on the board. About 15 seconds of continuous exposure worked here. If you're successful, the plastic will peel back and the resin will stick to the board. Note that we left some copper exposed. This will allow us to probe our board thickness in a moment. So go ahead, place the PCB back into the mill using the alignment bracket as your guide. Probe the material thickness using the built-in probing routine in the Bantam Tools desktop milling machine software. Load the SVG file and align it to the board design. Now, set the engraving depth for the SVG at 0.003 inches, 3 thou, and set the planned placement at positive 3 thou on the Z-axis. If everything is perfectly flat, the mill will cut at the top of the copper, barely touching it. But because board thickness can vary slightly, we're using a spring-loaded tip that will adjust to the small surface height differences. Now, with the engraving step successful, finish the board by cutting the holes in the outline. Be sure to disable traces. And there you have it. You milled your own PCB and applied your own solder mask right on your desktop.